Scenario 2, we've got our vehicle moving towards an object. So on the right-hand side, we've got our loader in this particular case, and that loader is going to be approaching the LV or pedestrian on the left in this particular example. So as that loader approaches, they should have their A1 awareness on screen, so they should have their situation awareness in general. If they get too close, they get their A2 alarm, and then if they continue forward, they get their A3. Fairly straightforward, fairly simple, but there's a couple of nuances with it that we're going to go through. So first of all, there's variations of that. There's the fact that that loader could be actually going reverse instead of forward. A lot of mining operations will require their loaders in particular to drive with the engine facing forwards rather than the bucket facing forwards. That's because the operator actually has more visibility looking out over the back of the machine rather than the bucket, particularly if there's something in the bucket. So that's really important. Whether the machine's going forwards or backwards shouldn't matter. Overall, that the problem is the same. Whether the pedestrians or the LV are slightly moving as they approach shouldn't matter. And then a really classic variation of this general approach is a workshop or a service bay. As you're approaching that workshop or that service bay, you potentially could be running into people there. It needs to be aware of. A really important consideration, if we look at center screen there, is the fact that our tunnels are not straight. You know, the graphic that I've shown at the top, the animation, we've drawn a nice, perfect straight line, but in reality, tunnels are rarely straight. Mining will follow the ore body, the path of least resistance, as much as possible, because building tunnels is quite expensive. So you want to keep it close to where you're making the money as much as possible. So tunnels are rarely straight. They have lots of kinks and dips and turns. They also are not flat, so they might have crests or dips in it to account for dewatering practices and things like that. So that needs to be considered in how we design solutions for this particular scenario. We also need to give some consideration to what we're calling the knock-on effect, where one machine may push another machine onto a third party. So in the image on the right in the center there, I've got a loader who has hit an LV because the LV is inactive. So the machine's turned off, there's no one in it, there's no passenger. And in some circumstances, that may actually be invisible to the system of the loader. So if it is fitted out with a particular CAS system, it may actually be invisible. But the loader may see the pedestrian and think that they've got plenty of room, so they continue to drive forward and they push the LV onto the pedestrian. So it's something that needs to be considered in this particular scenario. We've also just listed, to prompt people to get them thinking a bit, some example parameters to consider. And we've done this on a lot of slides, you'll see that, where they're different physical parameters that can affect the way the system works. So for example, the mass of the machine. If the machine is heavier than some sites, than some other operations, you may actually have to brake earlier in order to brake in time to keep your pedestrian in the yellow zone, or even in the green zone, if you will. The operating speed of the machine also has an effect, and the grade of the drive. If you're driving downhill versus uphill, it also has an effect on your braking. So we haven't listed every single parameter. That's not the intent, and it'll probably fill up the entire slide. But we wanted to prompt people and create the conversation that when you're thinking about this scenario, you also need to think about your parameters and how they affect managing this particular scenario, and other scenarios for that matter as well.